Alright, here we go. 2001, problem number 6, differential equation type problem. Let's get started. So, the function f is differentiable for all real numbers. The point 3 1/4 is on the graph. The point 3 1/4 is on the graph of f. And the slope at each point of x equals y, on the graph is given by dy over dx equals y squared times 6 minus 2x. Okay, first thing we got to do is we got to find the second derivative and evaluate it at that point. So we got to find d2y over dx squared, which is the same as finding the second derivative of this. So let's write that guy out. Okay, so we're taking the derivative of this again. And when we do that to the left side, we just get dy to y over dx squared. On this side, we're going to have to do the product rule and implicit differentiation. So remember, we're taking the derivative with respect to x. So whenever you do that, whenever you take the derivative with respect to x, and you're taking the derivative of y, you're going to need to have a y prime or a dy over dx after that. Okay, so first let's take the derivative of the y squared. Now y squared is multiplying to this guy, but we're not taking the derivative of him first, says the product rule. We take the derivative of the y squared, we get 2y. And then we would write a y prime, or we would write dy over dx. And then we multiply that by 6 minus 2x. Then we say plus. Now I'm taking the derivative of the second term. So y squared is chilling. Nothing's happening to him, and I take the derivative of 6, which is a constant, and so that's 0, and then I take the derivative of negative 2x, I get negative 2, so I'm just multiplying this by negative 2. Now let's simplify. Okay, now we're going to take out this dy over dx and sub in what we know to be dy over dx. So we got 2y, and dy over dx equals y squared times 6 minus 2x, and then we have times 6 minus 2x plus, minus 2y squared. And since d squared y over dx squared is already alone, we don't have to do anything else to this. We just found it. The next thing we got to do is we got to plug in that 3 1/4. So we got to plug in these two right here, because it says find this, which is what we did, and we then got to plug in the point. And just a reminder, this guy right here, this is what dy over dx equals. I took him out because what I'm trying to do is, I know that I'm going to be plugging in this point. I can't have dy over dx right there. Well, I suppose I could, but then you have to plug in the x and the y into this and then plug it in. So it's kind of just taking a shortcut, I think. Alright, so let's plug in our y and our x. So we got d2y over dx squared equals, and we got 2 1/4. Okay, I had to put it down there. Didn't have enough space up top. So let's simplify. 2 times 1/4 is going to be 1/2. And then 1/4 raised to the second power is going to be 1 over 8. And then I have to multiply that times whatever I get inside here. And I don't want to do too many steps in my head, because then I usually make a mistake. So I have 1/8 times, that would be 6. 6 minus 6 is 0. Oh, dang. That's all times 0. It just goes away. I don't even need to do the rest of this stuff. Okay, so minus, now I'm going to do that. So I have 2 times 1/8, because 1/4 to the second power is 1 over 8. No, that's not right. It's 1 over 16. Oh, I said that was 1/8 earlier. Right here. That should not have been 1/8. That should have been 1 over 16. But, like I said before, it doesn't matter, because now it's multiplying times 0, because we have the 6 minus 6 right here. Okay, so we have negative 2 over 16. You can leave your answer just like that. I know you want to simplify it. Divide the top and bottom by 2. Okay, the next one says find y equals f of x by solving the differential equation. Here's a differential equation with the initial condition of 3 1/4. Which is funny that they give us this again because they already gave it to us. They didn't have to do that, but they're being pretty kind by doing that. Okay, so we're going to separate the variables first. So we have dy over dx equals y squared 6 minus 2x. So we want the x terms on one side, the y terms on the other side. I'm going to get rid of this dx and put them over here. It's kind of like multiplying, but not really. And then I'm going to divide both sides by y squared. So piece out y squareds. If I divide this side by y squared, it'd be same as saying 1 over y squared times dy. And so now I have 1 over y squared dy on the left side. And on the right side, I have 6 minus 2x in parentheses with the dx. In the process of solving a differential equation, the next thing you would do after you separate the variables is you would integrate both sides. The left side, what I would do is, so I don't have this nasty little fraction, is I would move that fraction up, or move that y squared to the top of the fraction, so I have the integral of y to the negative second power dy. On the other side, you just integrate each of these terms one at a time. So you're doing the antiderivative of 6, which is going to be x, and then you do the antiderivative of negative 2x, which is going to be negative 2 x raised to the second power, but then you're supposed to divide by that second power. And don't forget your plus c. You always have to have the constant right there. And my mistake, that should be a 6. Okay, now the left side, if I add 1 to negative 2, it would be negative 1. And then I would divide by negative 1. And there's my plus d. It's kind of like a c's cousin there. We have 6x minus x squared plus c. Alright, let's simplify a little bit more. 1 divided by negative 1 is just a negative 1. And I don't want to have a negative exponent, so I'm going to have negative 1 over y. I moved this down so that the y has a positive exponent, but I don't have to write a positive 1 power. And then I went, well, I guess I didn't really divide because I'm still a fraction here. So anyways, negative 1 over y. And then this d, I'm going to move it to the right side. And I'm going to add it to this constant. And since we don't know what that constant is, we just keep that c. Because if you add or subtract a constant from a constant, you just get another constant. So we're going to say c. Some books would not say c. They would give you another letter for the constant, like A, B, C, D, E. No, we can't use E. Can't use F. G, maybe. Okay, so this is a constant right here. This is the general solution. This is not the particular or the unique solution to the differential equation. This is the general solution. So how do we find the general solution? We use an initial condition or initial point or a point on the graph. And so now I plug that point in from the graph. So we have negative 1 over 1/4 equals 6 times 3 minus 3 squared plus g. Now I only have g as my variable, now I can solve for it. We're going to come back to this general solution and plug g in to get our particular solution. So this would be, if I multiply bottom by 4, top by 4, these would go away, and I would get 1 on the bottom, the top I would get 4, so I get a negative 4 on the left side. The right side I have 6 times 3, which is 18, minus 9 plus g. 18 minus 9 is 9. I subtract 9 from the other side. Negative 12 equals g. And so my final answer is going to be, let's write it all nice and cleanly for my scorers. Oh wow, wait, that's not going to be my final answer. I just realized something. Alright, so we got negative 1 over y equals 6x minus x squared minus 12. Did I make a mistake somewhere?
Isn't it negative 13?
Negative 13? When I subtract 9? Yeah. Wow, I'm doing an awesome job with adding stuff today. Yeah, it should be negative 13. Okay, now we can't leave this as our final answer. Does anybody know why? Nobody knows why? Because the y is on the bottom of a fraction. Can't have that. Okay, when you find the particular solution, you got to have y alone, not on the bottom of a fraction. So what we have to do is, well, what I'm going to do, one way to do it is you can make the other side of 2 a fraction and do your cross multiplication thing, and so then you would have -1 equals y times 6x minus x squared minus 13. Trying to get the y alone, so then I divide both sides by this guy, and I would get y equals -1 divided by 6x minus x squared minus 13. I'm not going to waste some more time by cleaning this up. That is my answer. As long as y is alone, we're good. Even though they don't have a negative, mine does, which would make the denominator change if you distribute the negative. You see, look at my answer. Wait, where'd my answer go? There it is. Okay, so if I multiply this negative out right here, that would be a -6x, a positive x squared, and that would be a positive 13, which is the same thing right here, -6x. Okay, so you get a point for separating the variables. Just getting all the x terms and the y terms on the same side, that's crazy. 1 point for that. Another point is you get a point for the antiderivative of y and a point for the antiderivative of x. So there's 2 antiderivatives that we had to take. You get a point for each of them if you do them correctly. And then you get a point if you have a constant of integration for each of them, like the d and the c that I had up there. If you didn't have that, you would lose that point. But even if you didn't have that, well, that'd be weird. If you didn't have that and then you didn't find that, you're missing that when you start working on the initial condition, because that would have to be there for you to solve for it. And then you solve for y. So if you left -1 over y for your answer, you wouldn't get this last point because you didn't get y alone. Y has to be alone and not on the denominator. This is interesting. You can get a max of 3 points if you don't have a constant of integration. So you can only get 1, 2, 3 points, these first 3 points right here. 0 points if no separation of variables. So that just makes sense. I think that just makes it easier for the grader. Like, oh, they didn't even separate the variables, I have to look at the rest of the stuff.